For decades, we believed the great white shark was the undisputed apex predator of the ocean, the most feared animal on Earth. The perfect killing machine, unchanged for millions of years, the top of every marine food chain it entered. Then, in October 1997, something happened off the coast of the Farallon Islands near San Francisco that permanently changed everything we thought we knew. Two female orcas were spotted near a group of white sharks that had gathered to feed on a dead whale. What happened next was witnessed by whale-watching tourists on a nearby boat and subsequently documented by Point Blue biologists stationed on the island. Within minutes, one of the great white sharks, a large adult, had been flipped upside down by one of the orcas. Within seconds of being inverted, the shark entered a state of tonic immobility and natural paralysis that affects sharks when turned upside down. The orca then systematically extracted the shark's liver, one of the most nutrient-dense organs in any animal, with what researchers described as surgical precision. The entire event lasted less than 15 minutes. The other great white sharks in the area fled and did not return for weeks. This was not a fight. It was not a battle between equals. It was a demonstration of predatory intelligence so advanced that it has forced marine biologists to completely reconsider the relationship between these two animals and the very meaning of the phrase apex predator. Today, WildForge explores every dimension of the relationship between the great white shark and the orca. Not just their physical differences, but the deeper story of intelligence, evolution, and ocean ecology that this rivalry reveals. The great white shark and the orca represent two entirely different branches of vertebrate evolution animals that arrived at the role of apex ocean predator through completely different evolutionary paths, separated by hundreds of millions of years of independent development. The great white shark, Carcharodon carcharias, is a cartilaginous fish, a member of the class Chondrichthyes. Its skeleton is made entirely of cartilage rather than bone. The great white belongs to the order Lamniformes and the family Lamnidae, the mackerel sharks, and is the sole living member of its genus Carcharodon. The great white shark lineage is ancient. The genus Carcharodon has existed for approximately 16 million years, and sharks as a broader group have been patrolling Earth's oceans for over 450 million years, predating the dinosaurs by more than 200 million years. The great white is found in cool coastal waters in all major oceans, the Atlantic and Pacific coasts of North America, South Africa, Australia, New Zealand, the Mediterranean, and throughout the world's temperate and subpolar seas. The orca, or China's orca, is a mammal, a warm-blooded, air-breathing live-birth-giving member of the order Cetacea and the family Delphinidae, the oceanic dolphins. Despite the common name killer whale, the orca is not a whale at all, but rather the largest member of the dolphin family. The orca lineage diverged from other cetaceans approximately 11 million years ago, far more recent than the great white's ancient shark heritage. Orcas are found in every ocean on Earth, from the Arctic to the Antarctic, from tropical seas to polar ice, making them the most widely distributed marine mammal after humans. Recent research has established that what we currently call the orca actually represents multiple distinct ecotypes populations, so genetically and behaviorally distinct that some researchers argue they should be classified as separate species. The physical differences between the great white shark and the orca reflect their very different evolutionary histories. A fish versus a mammal, cold-blooded versus warm-blooded, solitary versus social. The great white shark is a large predatory fish with a torpedo-shaped body built for speed and power in open water. Adult females larger than males as in most shark species, typically reach 4.6 to 4.9 meters in length and weigh between 680 and 1,100 kilograms. The largest reliably verified wild individual measured 6.1 meters and weighed approximately 1,905 kilograms. The great white's most immediately recognizable features are its counter-shaded coloration, dark gray on the dorsal surface and brilliant white on the ventral surface, which provides camouflage when seen from above against the dark ocean and from below, against the bright sky. The jaws contain multiple rows of triangular serrated teeth up to 7.5 centimeters long. The great white may use 30,000 teeth over a lifetime, as teeth are constantly replaced. The great white has no eyelids, no ability to breathe air, and no capacity for the social learning that characterizes its rival. The orca is in an entirely different size category. Adult males typically reach 6 to 8 meters in length and weigh between 3,600 and 5,400 kilograms, making even a modest male orca substantially heavier than the largest verified great white shark. The largest recorded male orca measured 9.8 meters and weighed over 10,000 kilograms. Female orcas, though smaller than males, typically reach 5 to 7 meters and weigh 1,400 to 3,600 kilograms. The orca's distinctive black and white coloration, black dorsally with a white ventral patch and a distinctive white eye patch, is unique among marine mammals and varies subtly between ecotypes. The male orca's dorsal fin can reach 1.8 meters in height, the tallest dorsal fin of any marine animal. The orca's brain is approximately 4 times larger than a human brain, by mass one of the largest and most complex brains of any animal on Earth, with a highly developed neocortex associated with social learning, planning, and communication. The hunting strategies of the great white shark and the orca reveal the fundamental difference between these two predators and explain why their encounters consistently end the same way. The great white shark is a masterpiece of sensory hunting technology. It possesses electroreception through organs called the ampullae of Lorenzini, gel-filled pores concentrated around the snout that detect the electrical fields generated by the muscle movements of living animals. It can detect 1 part blood in 10 million parts of water. Its lateral line system detects pressure changes in the water from the movement of distant animals. Its vision is adapted for low-light underwater conditions with a reflective layer behind the retina that amplifies available light. And it can maintain its body temperature several degrees warmer than the surrounding water through a counter-current heat exchange system, a unique adaptation among fish that gives it the metabolic performance of a warm-blooded animal in cold water. The great white's primary hunting technique against marine mammals, particularly seals and sea lions, is the vertical ambush. The shark approaches from directly below at high speed, using its counter-shaded coloration as camouflage against the bright surface, and strikes with explosive force from beneath. The impact alone can launch a seal or sea lion entirely out of the water. After the initial strike, the great white often releases the prey and waits for it to bleed out, before returning to feed, a strategy that reduces the risk of injury from a struggling animal. The orca hunts in a completely different way, and its hunting strategy is not instinct but culture. Different orca populations around the world use different hunting techniques, passed down through generations by social learning, in the same way human cultures pass down skills. Orcapods in Norway have been documented herding herring into tight balls near the surface and stunning them with their tail flukes. Orcas in Patagonia intentionally strand themselves on beaches to grab sea lion pups a technique that must be taught to juveniles who practice in shallow water under adult supervision. And the orcas that hunt great white sharks, documented primarily off the coasts of South Africa and California, appear to have developed a specialized technique that exploits a unique biological vulnerability of the shark. Sharks experience tonic immobility and natural paralysis when inverted upside down. The orcas that hunt great whites appear to know this. They target individual sharks, work cooperatively to position themselves and the shark, and then use their powerful flukes and body mass to flip the shark upside down. Once inverted, the immobile shark is helpless. The orca then uses its conical teeth to puncture the shark's body cavity and extract the liver and organ that can weigh up to 25% of the shark's total body weight in some species, and is rich in squalene and other lipids. The rest of the shark's body is typically left uneaten. This is not opportunistic predation. This is specialized, culturally transmitted, cognitively sophisticated predatory behavior, and it has been documented repeatedly across multiple locations and multiple orca populations. Perhaps the most revealing aspect of the great white shark and orca relationship is what happens to great white sharks when orcas are present, and what this tells us about the ecological reality of who is truly at the top of the ocean food chain. In 2019, researchers published a study in Scientific Reports documenting the response of great white sharks to orca presence at the Farallon Islands, one of the most important great white shark aggregation sites in the world. The study found that when orcas arrived in the area, great white sharks immediately fled and did not return for the remainder of the season. The sharks' behavior trackers showed them leaving the area within minutes of orca detection and remaining absent for periods of weeks to months. This pattern was consistent across multiple years and multiple shark individuals. A second documented case from South Africa provides even more striking evidence. In 2017, multiple great white sharks were found dead along the South African coast, their livers surgically removed, with bite marks consistent with orca predation. In the months following these events, great white sharks virtually disappeared from the famous aggregation sites around Gansbaai locations, where they had been reliably present for years. White shark cage diving operators reported near total disappearance of sharks from areas where dozens had previously been seen. Researchers confirmed that orca activity had displaced the great white shark population across a large geographic area. The great white shark, the animal that for decades was marketed as the ocean's most feared predator, displays a fear response to orcas that is both immediate and persistent. This is not the behavior of a competitor. This is the behavior of prey. The contrast between the social and cognitive lives of the great white shark and the orca represents one of the most dramatic differences between any two apex predators that share an ecosystem. The great white shark is fundamentally solitary. While great whites do aggregate at rich feeding sites such as seal colonies and whale carcasses, and while some research suggests they may have loose social hierarchies at these aggregation points, they do not form stable, long-term social groups. They do not cooperate in hunting. They do not teach their young specialized skills. Each great white shark is for practical purposes an individual predatory unit operating alone. The orca lives in one of the most sophisticated social structures of any non-human animal. Orcapods are matrilineal, centered on an older female whose knowledge of hunting grounds, prey behavior, and ocean geography accumulated over decades provides critical survival advantages to the entire group. Female orcas can live for over 90 years, and their post-reproductive lifespan, the years after they stop reproducing, appears to be spent in an active grandmothering role, leading pods toward food sources and sharing ecological knowledge. Male orcas die significantly younger, typically in their 30s to 50s, but remain with their mother's pods throughout their lives rather than dispersing. Orca pods communicate through complex vocalizations, clicks, whistles, and calls that vary between populations in ways that researchers describe as dialects. Different orca populations have different call repertoires, and these dialects are learned socially rather than genetically determined. An orca born into one pod acquires the vocal dialect of that pod through learning, just as a human child acquires the language of their community. This social complexity, accumulated knowledge, cooperative hunting, and cultural transmission of skills, including the specialized technique for hunting great white sharks, represents a level of cognitive sophistication that the great white shark, for all its sensory brilliance and evolutionary refinement, simply cannot match. Both the great white shark and the orca face significant conservation challenges, but the nature and urgency of those challenges differ considerably. The great white shark is listed as vulnerable on the IUCN Red List, with populations declining across most of its range. The primary threats are incidental capture in fishing gear, particularly long lines and gill nets, set for other species targeted hunting for fins, jaws, and teeth, and the persecution that has historically characterized human attitudes toward sharks. Great white shark populations are difficult to assess because the species is solitary, wide-ranging, and rarely congregates in numbers large enough for conventional counting methods. Acoustic and satellite tagging programs have revealed that individual great white sharks make transoceanic migrations. Individuals tagged off California have been tracked to Hawaii and Japan, highlighting both the species' mobility and the inadequacy of purely local conservation measures. The orca's conservation situation is more complex. The species as a whole is listed as data deficient by the IUCN, reflecting the uncertainty about whether the various ecotypes represent distinct species with different conservation statuses. In the United States, the southern resident orca population, a small, genetically isolated group of approximately 73 individuals as of recent counts, a number that fluctuates from year to year, inhabiting the waters of the Pacific Northwest, is listed as endangered under the Endangered Species Act. These orcas face a specific and well-documented threat: the decline of Chinook salmon, their primary prey, due to dam construction and habitat degradation in Pacific Northwest river systems. Noise pollution from vessel traffic interferes with their echolocation. Legacy contaminants, including PCBs and other industrial chemicals, accumulate in their fat tissue at levels that impair immune function and reproduction. Other orca populations, particularly the large, wide-ranging populations that hunt marine mammals rather than fish, are considered more secure, but face threats from entanglement in fishing gear, vessel strikes, and disturbance from whale-watching operations. The story of the great white shark and the orca is ultimately a story about two different answers to the question of how to be a successful predator. The great white shark answered that question through hardware, 450 million years of refinement, producing sensory systems of remarkable precision, a body of exceptional hydrodynamic efficiency, and a set of behaviors encoded in biology rather than learned from experience. It is a predatory instrument of almost unimaginable precision, operating largely alone, guided by instinct, refined across geological time. The orca answered the same question through software, a brain of unmatched complexity, social structures that accumulate and transmit knowledge across generations, cooperative hunting strategies that no individual orca could execute alone, and the cognitive flexibility to develop entirely new predatory techniques in response to new opportunities, including, apparently, the opportunity to hunt the animal the rest of the ocean feared. Both animals are products of evolution. Both are irreplaceable components of healthy ocean ecosystems, and both face threats from human activity that require urgent conservation attention. But the Farallon Islands encounter of 1997 settled one question permanently. When the ocean's ancient sensory machine meets the ocean's social intelligence machine, intelligence wins. Thank you for watching.